So we are given a pair of simultaneous linear equations, and we're asked to write the equations in the form AX equal B, where A, X, and B are matrices. So in other words, they want a matrix equation. And so we do that, we write the coefficient matrix A. We're going to enter the coefficients 2, 5, 3, and 4. Of course, we want to keep the signs with them, right? Whatever sign this is, it goes with the coefficient. So positive 2, this is going to be positive 5, but we just write the 5 there. If it were a minus here, we put it as a negative next to it. Not in the center, but just on the number. If you had a minus 5y, we would have put it as negative 5. Now we put a 3 here. This plus goes with the 4 as positive, but we just simply write positive 4 there. So 2, 5, 3, and 4 are the coefficients, and those go into the coefficient matrix. Then we're going to have the variable matrix. The variable matrix is represented by the letter Kx. So this matrix coefficient matrix represented by A, the variable matrix represented by X, capital X. Now in bracket, we're going to have common X, common Y. These are the variables that we have to solve. And it's equal to the constant matrix. That's where we have the B. So A times X give us B. That's the equation. Now B is basically the 2x1 matrix with the constants 6 and 8. So we have, in this matrix, we have 2 rows, 2 columns. So the 2x2 matrix. This matrix here has 2 rows, 1 column. So this is a 2x1 matrix. 2 rows again, 1 column. So B is a 2x1 matrix. But this is the solution is now in the matrix equation format. AX equal B. 2 marks, easy, 2 marks. Now we are asked to calculate the determinant of matrix A. And how you calculate the determinant of a matrix? Well, this is matrix A. We want to find its determinant. So we write the symbol, these two poles at either side of the letter A, capital letter A, which really says the determinant of matrix A. And it's equal to, we multiply 2 by 4, right? 2 by 4, or 2 times 4, minus 5 times 3. 5 times 3. And this is going to be what? 8 minus 15, and that's going to be equal to negative 7. So we have the determinant of A being equal to negative 7. Now let's go down to part B. Part B is asking us to show that the inverse is equal to this. So the inverse of what? Matrix A is equal to this. So let us do that. What is matrix A? Let's make sure that we have it as 2, 5, 3, 4. Again, we get that from the coefficients. 2, 5, 3, 4. So let me just write matrix A being equal to 2, 5, 3, 4. I want to find the inverse. So how do we find the inverse? Well, the inverse of matrix A is equal to 1 over the determinant. We found the determinant to be negative 7 earlier. We're going to multiply by the adjoint matrix of A. To find the adjoint of A, we basically switch these two entries. So where we have 2, we put 4. Where we have 4, we put 2. So we're switching them. So 4 goes here, 2 goes here. Now what are we going to do with these entries in the non-leading diagonal? We keep them where they are. We do not switch them. Keyword, not. We do not switch them. But we change their signs. So this is positive 5, so we're going to make it what? Negative 5. This is a positive 3. If we change its sign, it becomes negative 3. So this is representing the inverse, 1 over the determinant times the adjoint matrix. However, we can rewrite this as a 2 by 2 matrix by multiplying the constant 1 over negative 7 by each entry. Let's do that. 1 over negative 7 times 4. Well, the 4 we replace the 1 on top, so it's going to be 4 over negative 7. We can put the negative at the side. So that's negative 4 over 7. Negative 5 times 1 over negative 7. Again, we're multiplying this constant by negative 5. Let's do that one. 1 over negative 7 times negative 5, put it over 1. This will give us the numerator of negative 5, the denominator of negative 7. Could we multiply across? Now, negative divided by negative give us what? Positive. So this is going to be 5 over 7. So far we have this entry, which is negative 4 over 7. Doesn't matter if the negative is in the numerator, the denominator, or the side, but I put it at the side. We have positive 5 over 7. Let's work on the next one. 1 over negative 7 times negative 3. Now this will become the numerator. So it will be 3, well, negative 3 over negative 7. Negative 3 over negative 7. This becomes positive 3 over 7. And this is how we got this. Then again, negative 1/7, or 1 over negative 7 times 2. The 2 will go on top, divided by the 7. But remember, it's negative 7. Put it at the side. Because negative times positive is negative. And if you notice that we have the same answer here. Again, it doesn't matter if negative is in the numerator, at the side, or in the denominator. Same answer. So we did show that A inverse is equal to this. Next, let's use the A inverse to solve for x and y. So how do we do that? Well, first thing, we want to write back the matrix equation that we had in the beginning. So let's go back to the beginning and look for the matrix equation, and we're going to write that back. So we're seeing the coefficient matrix 2, 5, 3, 4. So we go down, and that's where we have the 2, 5, 3, 4. Then we need to multiply that by the variable matrix xy, which is equal to 6, 8. So put xy equal 6, 8. All right, now what we're going to do, we're going to multiply both sides by the inverse. Remember, this is A inverse here. So let's do that. So we're going to multiply this side by the inverse. So let's rewrite and write the inverse. Negative 4 over 7. 5 over 7. Negative 2 over 7. And 3 over 7. Then we're going to multiply this side as well by the same inverse, A inverse. Which is going to be, let's write A inverse. And of course, we're going to multiply that by the constant matrix, 6, 8. So the constant matrix gets multiplied by the inverse, and this side over here gets multiplied by the inverse. Now remember, when you multiply a matrix, which is matrix A in this case, coefficient matrix, by its inverse, any matrix times inverse will give us the identity matrix 1, 0, 0, 1. Multiply that by the variable matrix. So these two produce the identity matrix 1, 0, 0, 1, where the leading diagonal entries are 1 and the non-leading diagonal entries, those are 0 basically. And then we will multiply this matrix by this. So let's do that. We're going to multiply row by column. So when you multiply this row, row 1 by column 1, this is row 1. Remember, rows go from left to right, or right to left. In other words, horizontally. Columns, vertically. So we're going to multiply entry 1 by this entry 1. Negative 4 over 7 times 6. This gives us what? Negative 24 over 7. This is our side work. You can use your calculator to do this, by the way. Negative 4 over 7 times 6 plus 5 over 7 times 8. Do it one time and put your answer in. But let's do it. I'm going to take my time to do this since I'm not using my calculator. Negative 4 over 7 times 6 gives me negative 24 over 7. That's first by first. Then we're going to multiply second by second. So that's the first by the first, then second by second. Row 1 by column 1. 5/7 times 8 gives me 5/8 40 over 7. So I have to add these two entries. So when I add negative 24 over 7 plus 40 over 7, what do I get? We keep the denominator of 7, and 40 plus negative 24, or negative 24 plus 40, that will give us what? That will give us 16. So we get 16 over 7. Now it's easy to wonder why didn't we get a whole number? Well, 16 over 7 is a number. It's just that it's a fraction. And it cannot be broken down any further. Of course, we can write it in other forms, as in decimal or mixed number, but we cannot simplify it any further. 7 is a prime number, and 7 cannot go into 16 without a remainder. So there's no other common factor of 16 and 7, but 1. So we will leave it as 16 over 7. Let's work out the other row, so that's row 2, which will now multiply by column 1. So multiply row 2 by column 1, we're going to get the first by first, so that's 3/7 times 6. 3/7 times 6 gives us what? 18 over 7. So that's first by first. I'm going to add it now to second by second. So let's work out the second by second. That's negative 2 over 7 times 8, which gives us negative 16 over 7. So remember, first by first, we got 18 over 7. Added to, so we're going to put a plus here, added to what? Second by second, which gave us negative 16 over 7. Now remember, same denominator, so we keep the denominator. 18 plus negative 16, this becomes minus. So 18 minus 16 is 2, so our answer is 2/7. So we have two answers, 16/7 and 2/7. Now remember, whenever you decide to multiply an identity matrix by a matrix, you will get back that matrix, because the identity matrix operates as what? 1. So you can get back the x, y. Any matrix that you have next to the identity matrix, you'll get back that same matrix. So working this out, we'll get back this. And this will give us 16/7, and we have 2/7. Now when two matrices are equal, what are we told? When two matrices are equal, that their corresponding entries are equal. So x corresponds to 16/7, and y corresponds to what? 2/7. These are our answers. Now before you assume that the answers are not correct because we didn't get a whole number, let's check. 2 multiplied by x, which is 16/7, plus 5 multiplied by, let's put 5 here, 5 multiplied by the y, 2/7, we should get 6. Let's see if that's the case. Now 2 times 16, that's 32, so that's going to give us 32/7. And 5 2s, that's 10. That's 10/7. 32, we're going to keep the denominator, add the numerators. 32 plus 10 is 42. And 7 goes into 42 6 times, because 7 6 is 42. So we did get 6. That's correct. Let's check the second equation. 3 times x plus 4 times y. Remember, x is 16/7 and y is 2/7. So x is going to be what? 16/7. That's what we got when we worked it out. And y being 2/7. Right, so let's just double check that down here. Yes, x 16/7, y 2/7. Now 3 times 16, that's going to give us 48/7 plus 4 2's, because y is 2/7, so this is 2/7 here. 4 2's, that's going to give us 8/7. And 48 plus, now I might add in the numerators because the denominator is the same. 48 plus 8, that's 56. Now 7 goes once, and 7 into 56 goes 8 times, because what? 7 eighths is 56. So 8 is correct. So both worked out to be true. So we know that these answers we have here at the bottom were correct.